Fantastic. Well, thank you, Graham. What a great start to your workshop today. Honestly, all the presentations were really strong. And I think what we'll do over the next 15 minutes is build on them, focusing on a single use case, an actual implementation of all the motivating concepts and interests that were just discussed for the last hour. So hopefully today, this next 15 minutes will be a synthesis and an implementation of those ideas. And particularly, I'm going to go into a bit of the mechanics of the abstraction layer that German probably spent the most time on, but what that harmonized, multi-standards-based domain model could look like, and how it drives automation end-to-end these 5G RAN scenarios. So again, thanks everybody for your time today. Really great workshop. So, yeah, thank you. So I'm not going to go into, you guys go through GPP, the 5G standards, and I think what we're going to focus on today, of course, is the service-based architecture and the open APIs and what they afford to the industry, right? The affordances of this architecture, of this design that they're putting forward. And what it really does is it's not just about 5G itself and the 5G value proposition to customers, but also the operational automation and operational benefits to the operators themselves and the MNOs. So that's what we're going to focus on, right? We're going to be focusing on using these interfaces to drive automation and a programmable infrastructure. Next slide, please. So we're going to present a no code, so a fully declarative. It's going to be fully model driven. It's going to use an abstraction layer, much as was described, a multi-standard abstraction layer, to provide the metadata and the domain semantics to drive extreme automation in this network. And so it's going to be a no code, a single platform-based workflow. So you're going to have essentially an end-to-end orchestrator driving all of the coordination between the services, as well as the integration and configuration of all of the participants. And that's going to all happen through a single workflow. It's going to also include some federated aspects. So it's going to show how such a platform could not only drive the end-to-end automation, but could work in conjunction with operators' preferred vendors and their preferred both at the VNF, CNF, PNF, but also as well as third-party controllers, orchestrators, and other cloud-native tools. But the key, again, I think German really spoke to this, was that you really needed an umbrella over the top, right? You needed an umbrella abstraction that your integration and automation is done best, as she described, at the layer above. That's what EnterpriseWeb is really all about. It's about an EnterpriseWeb. It's about that abstraction that gives you that end-to-end kind of control. In this demo, it's going to run on Amazon, and it's going to be consuming Amazon services. We're also brought in Red Hat, so we're going to be using, showing how OpenShift, we can actually work with both EKS on Amazon, as well as Red Hat OpenShift and Ansible. We're going to be deploying the Open5GS core on bare metal in Amazon, as well as Radisys OpenRAN. We're going to do an enhanced 5G core. So we're going to use Fortinet for security for an enhanced 5G core. And then we're going to do an enterprise business app. And this use case today, I'm just going to describe the use case because I only have 15 minutes. After this, we're going to post a demo to YouTube that's going to walk through everything that I described here in the next 15 minutes. So thank you. So this gives you the network service topology, and it shows you a fairly rich scenario where you have the open core properly disaggregated with control plane and user plane. You have the open RAN, as well as you have document DB, and you have the firewall. So again, we're going to just move right on so we can go into the heart of that. Next slide, please. This gives you an sense of the solution architecture here. Again, it's hosted in Amazon. So this is our solution software, CloudNFV, our telecom solution, deployed through the marketplace at Amazon into a couple of empty zones. We then deployed OpenShift onto bare metal as well as Ansible. We run on RHEL. So EnterpriseWeb essentially stood up this entire environment, both the solution environment, as well as the ultimately we're going to deploy the 5G core, as well as the Open RAN, etc. Next slide, please. So going back to what was essentially been the thread connecting all of the presentations today, is that EnterpriseWeb, I think there was a slide before this. Can you back up one? There you go, thank you. EnterpriseWeb is a thesis, really. It's a thesis that to be programmable, you need a model over the top. And not just any model, it can't be a hierarchical model. It really needs to be a graph-connected model. And the reason it needs to be a graph-connected model is you need a graph to properly map the relationships between all these industry standards, right? You would like to have one connected data model that represents all of the open APIs that your services will traverse. And this is that, right? Out of the box, we give our customers this model. It's fully graph connected, it's flexible, extensible, it's adaptable. You can extend it with your own internal information model. And of course, just in this little slide here, we're just giving a representative slice, sense of the standards involved. But you can see ETSI NFV, OASIS TOSCA, MEF LSO, 3GP, 5G, TMF Open APIs, as well as cloud concepts. And the reality is you need all of these to do the kind of automation that we've been discussing today. You know, we've been talking about the integration aspect, but we also talked about the testing, we talked about assurance, and even CI/CD. Well, to cover all of that, you really need a rich domain. You need a rich supply of not just metadata, but also the relationships, so you can actually have an understanding. So a system, machine readable, that you have a model that's machine readable, so a system can do that extreme automation. So we're featuring this ready-to-use telecom operation model, and that model will essentially be the single source of truth for everything. It's going to support model-driven onboarding. It's going to support declarative composition of intent-based network services. It's going to support the deployments and zero-touch network and service management. By the way, we ran, our company, EnterpriseWeb, ran the first ETSI NFV POC, CloudNFV, and then we also ran the first ETSI ZSM, first zero-touch network and service management POC. So we've been demonstrating the ideas inside telecom for a long time, but only recently, and I think honestly it has a lot to do with 5G, MEC, and Edge, people are now looking to higher level abstractions for automation. So we're sort of starting to lift our head up above discrete interfaces to say, how do we connect across, how do we coordinate across these domains? How do we do anything end to end? So you also have to do app and service lifecycle management, app and service lifecycle management, right? Because your services are going to have life cycles, but you're also the participating functions are going to have life cycles as well. And you want to be able to manage that. You want to do in-service upgrades where you can, et cetera. And you want transparency for testing and troubleshooting. And the idea in it is to actually have a unified model that's self-distributable that can then give you, provide the consistency that supports your automation environment. Next slide, please. And this sort of gives you an idea, right? So this model is essentially representing, if you can see here, it's allowing you to create logical objects that represent, almost like digital twins, elements at the application layer, elements at the resource layer, elements at the network layer, and they're all going to essentially be modeled as essentially these virtual objects or digital twins. We have their properties, we have their constraints, their dependencies, their behaviors, all richly modeled as well understood, isolated, immutable objects that are typed in the system. And that's what gives us the basis of declarative composition and intent-based management. Then when we deploy these things, we can use that same model to interpret events, look at the state and telemetry that's coming up, push down configurations, and manage the overall SLA. Next slide, please. And here we get, as a result of that, we get this autonomic closed loop control, right? Because we're now using a model to onboard the solution elements, compose services, to automate the deployment of those services and the configuration of those services, manage their assurance, as well as monitor all of the connected interfaces. And the reason you can do that is you actually have a model, because if you it's not enough to just say you're event driven, right? You have to understand events. You don't want to hard code your events. You want your events to be able to be interpreted against the model, so the system can then understand interpret the events, essentially use the events to translate policies, and then optimize next actions, right? whether that's a mitigation, a scaling behavior, a healing behavior, etc. Right? And the model is then providing for all of that. Right? It's not enough just to say you have metadata. It's not just enough to say you have events. You have to actually understand your events so that you can take proper action against those events. Also note that there's a northbound API as well that's pushing up to the customer portals, analytics, AI, ML, and billing. And all of this is actually deployed in production. We're into production with Tier-1 Telecom. So this whole scenario is not 4 years down the road. This exists today. And I'll also point out too, because ONAP came up a couple times during this conversation. ONAP, of course, represents a great industry collaboration. But I think it's fair to say, and I think people have been hinted at it in this meeting, is ONAP's a better idea than it is an implementation, right? It's bloated. It's gone off its original vision. It's really not a cloud-native model-based event-driven system. It doesn't have a single unified model that graph connects everything into a single event-driven automation space. But what we can do, though, is I'm not saying that to knock it. I'm saying it has great reference models. And we've actually already done this for various customers and various presentations where we've actually onboarded relevant ONAP concepts and can actually interoperate with ONAP interfaces. So that just becomes another extension of this model if a particular telecom wants to go down that route. Next slide, please. So now we're going to talk about the application of this. And this is what our demo will be. And I'm going to move pretty quickly. And again, we'll post a demo of this. It'll be probably like an hour long. It'll be a lot more methodical, and you'll be able to go through that at your leisure. So I'll go through pretty quickly right now. So, of course, in this demo, we'll have a couple of things pre-baked, right? EnterpriseWeb is in the Amazon marketplace. We are an Amazon partner. Amazon validated the solution I'm presenting to you. We've gone through the the Amazon well-architected framework and vetted against that. So we exist in the Amazon marketplace. We get deployed over into Amazon zones with EKS and OpenShift. We deploy OpenShift into the environment, into that bare metal environment. And so with Ansible co-resident, and we've modeled Open5GS and ORAN. To give you an idea, so those components of the solution as far as the demo is concerned are either all deployed as far as the implementation environment, or they all exist in the catalog composition perspective. But just to be full disclosure, we onboard virtually anything in 30 minutes to 2 or so hours. So something like that's fairly straightforward, like a router, like a Cisco Juniper Sienna router, we can onboard that in about 30 minutes. It would take something that's a little more disaggregated, like a Metaswitch IMS, and because it's disaggregated, it takes about an hour. To do something much more like complex, that's more like a multi-component, like a 5G core and ORAN or a RAN, then we're talking about probably 2 hours, just to give you a sense of that. That's all done in a model-driven way, no code. The only code that we might be working with is any string that we need to bring into our model in case we need to invoke it to configure it or something like that. There's some proprietary CLI, et cetera. Once we have things in our catalog, we just compose them. And the only thing that the service designer needs to do is model their service graph, find their service chain policies and their SLAs, and that's it. And you could literally model a 5G core, an enhanced 5G core with Open RAN, and you can model that service in 5 minutes. And it's no hard code. It's fully version controlled. It's adaptable. It can be extended later on down the road. It's fully agile. It's all defined in metadata. The system generates everything else for you, right? It's going to generate a full deployment and configuration workflow based on the set of components you define. So if there are federated solution elements, it's going to generate plans for those to pass down to those federated elements. In this case, we're working with Ansible. So when it comes to something that might be, I think, configuring Fortinet, we're going to use Ansible. So we're going to actually pass a plan. We're going to invoke Ansible to run a playbook to configure. But we could also do that directly. And so all you do is you model the things, essentially you model your service logic, publish it that, and you expose an API for ordering. The system then, next slide, please. The system then essentially executes a generic workflow that's been contextualized by the service design, right? So the system generates, so establish infrastructure, instantiate the service, configure the service. You can imagine those are all common steps that would occur in most all of your deployments. In this case, the details matter, right? So it's going to be generating YAML files for CloudFormation to provision the VPC network. It's going to generate JSON payloads for EKS and OpenShift, JSON payloads for to provision the subnets, and you got JSON payload to configure the DNS. And you can already see this is a really rich scenario, right? Rich multi-vendor, multi-controller, multi-domain, right? So lots of richness here. Then the next step, it's going to then, with those things then being done, it's going to deploy the Open 5G core, deploy the Open RAN, deploy Fortinet. It's using OpenShift to deploy the Fortinet, and it's going to connect to AWS Document DB service. Then it's going to configure all the applications. So we're talking about zero touch to do the deep networking and application, right? So the full top to bottom, right? If you look at, Amazon's written some, I know we obviously work very closely with, they've written some wonderful strong engineering blog posts describing related use cases. But if you look at them, they actually talk about writing manual scripts, doing point-to-point integration. They came to us because they thought we could help accelerate time to value from MNOs and telecoms, that we could actually give a faster deployment time and zero-touch automation, which they're not doing. And in this case, we wanted to show Red Hat too, because we know that Red Hat, as far as hybrid cloud, is super popular. And we wanted to show whether it's, in this case, we're standing up Red Hat ourselves, OpenShift ourselves. But of course, we could use ROSA, the Red Hat OpenShift, as a service from Amazon as well. Next slide, please. And the system is going to treat this all as a transaction. It's going to treat every stage of this process as a transaction, as with its own sub-goals to achieve, and the whole end-to-end process as a transaction. And that's really critical because the system actually it's going to execute as many steps in parallel as possible, but essentially it has to move through these stage 1, stage 2, stage 3 gates, right? You can't go to stage 3 without going through stage 1 and 2. It's just logical. It's a logical constraint. And if at any point it fails, it's going to apply compensations, right? Because you need that, right? Otherwise, you're going to have resources spinning and functions spinning that for which you have under the control of no model, right? So it's actually going to apply and then report back through any dashboard or portal. And I think that's it. Next slide, please. So this essentially goes through the steps of the demo that we'll provide. I'm not going to bother reading through this. But most of the time, the demo is just to show you the catalog, show you the elements, show you how things are connected to the graph, how the graph connects to standard interfaces, how you don't have to do any manual integration, how the composition is deployed, how little effort has to be done to do the declarative composition, and how the rest is automated, including the assurance and the monitoring, the assurance, and the mitigations are all done through the system. In the demo, we're actually going to also show is as soon as that 5G core network is deployed, we're going to expose that through a customer portal, and then the customer can then deploy an application through that new open 5G network that we just deployed. And we're talking about that whole end-to-end, that whole scenario. We can do all of that. The composition, the deployment, standing it all up, assuring it, exposing it, deploying an enterprise app onto that network, and that whole process is less than 5 minutes. And it's fully traceable. So I think, again, I'm echoing a lot of what the speakers spoke about today, which is the need for higher level abstraction. 5, 6, 7, 8 years ago, when we first joined ETSI NFV and the second meeting in Santa Clara, nobody was talking about high level abstraction. We were trying to promote these ideas that you needed models to drive at the application layer. You need models at the application layer, not just at the network layer, but at the application layer to drive this kind of sophisticated automation. And I think now the industry is recognizing that. So that's the presentation. Really, the main point is that these things are possible today. It's all done. We're not a standards organization. We're providing a graph structure for a graph data model, which you can exploit those standards, extend those standards, and use them to drive your automation.
Hi, I'm Bill Malik, Chief System Architect with EnterpriseWeb. I'm going to be giving you the demo now. As mentioned, programmable 5G with Open RAN infrastructure. Through the course of the demo, I'm going to play a number of roles or personas that will span across AWS interfaces, the EnterpriseWeb modules themselves, and then some customer portal samples that we stood up just to show you how ordering can be done. I'll come back to this slide between every transition so that you always know who it is I'm playing the role of and what it is that I'm doing. We're going to begin with looking at the system as a cloud administrator, someone who's ordered an EnterpriseWeb instance out of the AWS marketplace, and we're going to take a look at what's already been deployed and what's already been done for this demonstration. So we have a simple little command line interface here, a proxy made up for the AWS CLI. It's going to give us information on the CloudFormation stacks that have already been deployed. We'll see that there's two. There's the EnterpriseWeb platform itself. A simple YAML file was used to deploy it onto AWS, and we can access it either from a web browser or from APIs. It deploys as a series of cloud-native pods that are all clustered together. Each one has a specific purpose. They're really divided along your kind of typical roles within telecom. So an application manager solution will be out there for someone like a developer to onboard VNFs and CNFs. There will be a service manager for actually doing the composition of the services, a catalog and inventory, and so on. All of them will have a similar look and feel, and once you've learned one, you can kind of transport those skills to another. It really just varies on the kind of subject matter that you're going to be working with, managing, or automating in eWeb. That's all, again, cloud native deployed, scales out and does all the kind of cloud native best practices. Right here it's deployed into EKS. If I go back to the proxy, you're going to see the second piece of this is that we actually have an OpenShift deployment that's been stood up by EnterpriseWeb as well. So we deployed this in advance of the demo itself. We can go in and we can see the OpenShift sort of splash page, and we can see the kind of vanilla K8's dashboard that's already been stood up as well. What we'll do is we'll spend most of our time in the kind of EKS sort of Kubernetes standard dashboard just to see what's been deployed, but that kind of visibility is all available through EnterpriseWeb. We can get a full trace and full depth of what it is that we're managing, any component that we may have stood up in advance, including health and all of the kind of lifecycle management that surrounds it. And then this is, of course, integrated through all APIs into eWeb without writing any manual code at all. You can see we have an instance of Ansible Tower that was stood up before and a control proxy right now running in Kubernetes. This will become a much busier solution as time goes here. As we start to deploy things like the core, we'll be able to examine the various pods and so on that have been stood up. Okay, before we get to composing our service, I'm actually going to take you into one of the design time modules. We call it our model manager. It's really just a component that's built for someone like a system architect or an overall cloud architect to be able to go in and look at the models that are driving all the automation that you're going to see. So I log in to this module playing that role, and what I can look at are all the sources of graphs that have been modeled in EnterpriseWeb. You have the overall graph of cloud concepts, or really our upper ontology that supports complete distributed applications. And then you should see some things that include standards-based models, ETSI, etc., that allow us to import their kinds of artifacts and automatically map them, and then fully automate them when we map them to our ontology. And then you'll see some other things like an Amazon Web Services domain and a Red Hat. If they're partners or someone we work with very closely who has a rich domain, we're able to model that inside the system so that we can automatically interact with things like their APIs, their underlying systems, or their data models. So I'll go into the Cloud Concepts domain here. And what you're going to see is that these are all the kinds of core elements that are going to be underlying really any distributed system. If we look at the graph here, you're going to see that it's quite vast, and it really covers the full spectrum of things that are needed in terms of such a, an automated space. You can see artifacts that include everything from process models to documentation, formats, Yang, etc. It will include things like protocols and really all the major components that are needed to be able to automate these applications in the space, telecoms especially, but really any cloud application. I can look up any one of these components if I want within my catalog, and immediately what I find is the sort of zoomed in details about any concept that we've modeled. So I can go in and I can look at, this is what we call our virtual function package. It's the kind of wrapper, if you want, that we put around any cloud application. So a VNF, a CNF, even something like a full-on system that might be deployed, namely an OpenShift, for instance. And really it's what we surround that kind of an artifact with so that we're able to fully automate its life cycles and its operations. You can see the graph down here, and what we can do is quite literally walk into it. We can find out what the kinds of artifacts are that you might want to be figuring around it, things like load balancers that it might have to interact with, tenant spaces. And as you walk this more and more, you'll see, again, more specific information about the kinds of objects that you're walking into. And all of these things are within EnterpriseWeb described as a graph. So we can walk into the elements, the properties, the methods, and so on that they all execute and that we automate over the top of. So this is really what's underneath the sort of no-code environment. At any time, this has a very rich data model that's behind it that we can expose as, again, our internal model, which is either JSON, XML, or you can even look at it as text that describes really all of the elements, where they're derived from, whether it's our meta model, something that might come from ETSI, and so on. Really, you get that full trail of information that's representing an object, including things like an interface for how you might operate with it. So we produce standards-based interfaces even for the objects that come out of this graph. And this extends into the other domains as well. We can go in and look at something like the AWS domain itself, and what we'll see are sort of familiar objects that have been then mapped to EnterpriseWeb concepts. Now we're going to proceed to actually use these models and take advantage of all the automation that they offer by going in as a service designer and actually utilizing objects that were mapped to this model. Now I'm going to play the role of the service designer, where we're going to spend the bulk of the demonstration itself, or do the bulk of the work. First, what I'm going to do is just take a quick look at the fact that if I log into that service manager module, I'm going to be able to look at the solution elements in our catalog that I might use to compose my solution. And then what I'm going to do is actually walk through a sort of model-based process for actually composing it. So I'm going to log into EnterpriseWeb, playing the role of service designer. I can see my catalog here, and that it composes the kinds of elements that might be needed by someone playing my role to actually execute one of these network services. It includes a series of VNFs and CNFs that have already been onboarded and modeled in EnterpriseWeb. You can see some cloud hosts, everything from a Google Cloud platform to the AWS zones that we might be deploying into. And it's really going to span the sort of breadth of components I might want to compose my solution out of. All of these have rich models behind them, lifecycle management, and so on, and they're all available from my catalog here. What I'm going to do is actually walk through now composing a new service. So I'm going to create a new network service template. It'll be a 5G core with firewall. So now what I'll do is I'll proceed to fill in the kinds of parameters here that I want in my service. I'm going to start by composing things, and this is really the core of the work when I'm actually building a service in EnterpriseWeb. I'm building that service graph from components in my catalog, and then what I'm doing is configuring each one for purpose. As I work further and further on this service, what you're going to see is that the context with which I'm building will sort of allow me to do more and more with the service. To say that a little bit differently, if I add something like a connection to an AWS service, the system will be aware and be able to take advantage of those interfaces, those services, those kind of operations just sort of automatically. So what I'm going to do is I'm going to pick from my catalog a couple of components. I'm going to pick the firewall that I want to be looking for. So in this case, the Fortinet firewall. I'm going to pick out the user plane functions. And all of these have been modeled in advance, so I can take advantage pretty quickly, add things like the ORAN user plane or the 5GS user plane, for instance. And what I'll do is I'll just go ahead and actually do all of this right away. You can see it's pretty quick to be able to do this kind of a thing, and just really to be able to identify the packages that I want the system to manage on my behalf. And then it's really just a matter of me being able to arrange them into the order that I want. I'll take my firewall, I'll put my user plane down here. I'll say that the ORAN will connect directly to the firewall, back into our user plane. And then at any time, as I'm modeling this kind of a service, I can drill in on the details here, right? So things like service chains and so on that are normally managed, potentially another tool, an SDN component, really what we can do is just quickly click right into them. We can find what interfaces, and all of this has been modeled in the sort of upstream component itself. This all comes down from the metadata that's in there and the connections. It understands what the actual interfaces are, what ones we want to turn on or off. We can go further with the service chaining and introduce things like policies. For instance, we may actually want to say that this firewall might only be available to a customer with a gold status, for instance, those kinds of things. So that it really becomes a very rich kind of modeling capability where I can decide without writing really any code whatsoever what I want things like my service chains and so on to look like, and have the system really take care of the additional detail on my behalf. I'll go ahead and actually add the rest of the components that we want here for our solution, but you can see it's a matter of really just selecting from our catalog what we want and connecting them in the right sort of way, and the system is aware of things like the interfaces that need to be bound between the different components. So pretty quickly I've got my sort of bare, if you want, bare bones kind of service description. The problem is though, I want to be able to do a little bit more than just this. The system will deploy this out of the bat for me and take care of any dependencies that are required. But as I sort of start to look at this, I actually want to make some choices. I want to say things like the fact that this is actually going to be a VNF or CNF that will be applicable to a slice rather than sort of shared infrastructure across all of the services. The little details like that are just pushed to the surface here, and it makes it easy for me to start to be able to go in and configure these kinds of choices with regard to deployment. As far as things like my firewall, I can look and I can identify hosts that may have already been deployed or domains that I want to deploy this into. But the fact is that there's some special requirements here that are needed for actually delivering this 5G core. If you look at some of the source materials we provided, you'll see that there's a certain description that's required as far as through CloudFormation for deploying the additional things like subnets and VPCs and stuff that you can't know by just simply connecting up your service graph, infrastructure requirements. So the nice thing with EnterpriseWeb is that we can actually go in and just use the interface itself to be able to do things like take an artifact like a CloudFormation template, for instance. You can see a number of different components here, even SASARs and so on that we might want to use. Well, we're going to take that Open5GS infrastructure, upload it into the system, and simply tag it as a CloudFormation template. Now what the system does is it will pull it apart, it will parse it, it will create any of the additional, if you want, the real concrete YAML that will be deployed onto CloudFormation based on how we use this. But what's nice now is I can go in and I can say that, well, that ORAN component, I want it to be deployed either onto that existing Kubernetes deployment and supplement it with any of the additional detail that comes in through this YAML file, or I want to literally stand up a new piece of infrastructure here and have the system really work out all that detail for me. So what's nice though is that all I had to do was really upload that file and the system introspected it, and now I'm able to go in and make my sort of choices as to where I want to deploy this. The other thing is I'd like to actually be able to deploy a DU in addition here, right? So I'd like a distributed unit. So let's go ahead and do that. Let's add an ORAN so that this sort of completes our chain here. So let's go ahead and do that. And it can be dynamically allocated. That's fine. So we've got our sort of full network service, but there's details about these components that we may want to actually work with. And in fact, one of the big ones is that this OpenGS, it provides a sort of default control plane component with a DB that's built in, a MongoDB, but really the superior implementation, especially on AWS, is to use one of their services, their document DB service. So what we'll do is we'll actually just pick it out of our catalog. We've already got these components registered. We've got the Route 53 DNS. Let's add that first. So this will be our DNS. What we'll do is we'll link that to our firewall, and all of the integration that's needed between them. When I configure the firewall, it will automatically flow through to my DNS. All that kind of stuff is going to be handled by the system. And finally, let's add the additional service. So let's add the document DB. So document DB is going to be here. Now this is the nice part about it, right? If I come in and I say that I want this to be connected to my control plane, what I can do now is if I start to configure my control plane, all that information is sort of available to the system. It's now an option for me to be able to use this service for the DB without any manual integration whatsoever in this kind of a circumstance. Even things like the secondary indexes and so on that will be used eventually have been generated by the system for me. And I can go on and I can add additional affinities and so on. We're going to go for a minimum sort of deployment here. But now what I've done is I've stood up, or I've created the graph which will represent that network service with all the connected components, even ones that are based in infrastructure. I've defined any parameters that I might want to use, and I have one additional component I want to run an Ansible script as part of this. So what I'll do is I'll just upload that, right? I'll flag it as an Ansible playbook, and the system is able to introspect these things, see what kind of compatible types I might have. But now that I've sort of supplied the full information, I've identified the packages to be deployed, I've added any additional artifacts that I might want the system to be able to work over. Now what it will do is actually generate for me a deployment workflow. So this is really the core piece of automation. It's going to expose to me a workflow that will actually span all the different connected components that need to be done. So you can see this looks a lot like that slide that we had earlier. There's a service to check it on demand, which I can sort of slide into place here where I might want that task to be run. But what I'm looking at is quite literally the set of tasks and stages that are going to be needed to carry out the automation of this service. I can see that at the beginning, the setup really spans from working with things like VPC to EKS, and even updating the DNS itself, instantiating the various components here, including some of them that will actually need to be run through OpenShift based on pieces of the model or constraints that were sort of present when I selected the package. And then at the end, it's going to be to configure, including, again, running through and actually taking that playbook that we uploaded earlier and actually running it through the through OpenShift into Ansible, and then deploying, executing actually within wherever that firewall this container happens to be. So there's a lot here that's already been described, and what's nice is this is a state chart description. All of these have drilled down. If I want to go into the detail of them, I can, but by default, the system is really trying to make it easy for me. I don't want to have to go to that level of detail unless it's required. And at any time, I can simulate what that sort of workflow looks like. I can pop in and see what those steps, sort of how they logically work one after another, including things like the fact that these kinds of operations can actually be run in a kind of parallel manner. And as much as possible, all these operations will be executed in parallel. It's just constraints that might force them to be run in some sort of order. And what I can do is kind of walk through what that's going to look like, instantiating the various components. And as I kind of walk through this, you'll see that it ends up being really just a process that's kind of nice and linear, and I can walk back and forth through it in any sort of order that I might want to see how the different steps might unfold. In any case, what I've got now is I've done the sort of minimum required modeling for the system. I talked about it a lot, but it really only took me a couple of minutes to identify the components I wanted, add a few policies and SLAs along the way, and have really what's going to be now a network service model that the system can execute for me. So I'll go ahead and add that to my catalog and publish it. And now what that does is it makes it something that's now going to be available through any APIs or external services that might be tied in so that they can start ordering the service. And now that the service has been published, I'm going to actually play the role of a business customer who's going to order that service through an external portal. Here we stood up a simple little UI over the top. All of the ordering APIs from different organizations such as TMF, ETSI, etc. are all exposed out of EnterpriseWeb. So what we can do is we can use standards-based methods to be able to order instances. Here we're just looking at a simple UI where I can select that product that's now being published, give it some sort of a name, and then place our order, and the system's really going to take care of the rest for me. So if I play the role of a NetOps engineer now, I'm going to look at two things. I'm going to log back into the system and I'm going to look at that Kubernetes deployment. So if I go into Kubernetes now, what I'll see is that I now have a number of different pods that have all been deployed as part of this and all been managed as part of that solution. So if I log in now, what I'll find is that that service that we had published earlier in my catalog, I can click into it and I can find out information about any orders that might have been placed. So in addition to the sort of case information, history and so on of the network service model itself, I can actually see instances here in my dashboard, and all of this is available through APIs. It can be streamed into inventory systems, etc. But I can see the health of that instance that we just stood up, when it was placed as an order. I can drill into the detail of it. I can see things like a host name that was stood up as part of the configuration. I can look at the life cycle itself, and this is where we get a full history and trace of what the system did in response to that order. It's an evented system. If we had other events occurring, things like health checks, migrations, scaling, etc., each one of those would show up here as an event. In this case, what we want to do is look at the trace of what the system did in response to that order. So what we can see is actually everything from the order being placed right through to what components in the EnterpriseWeb solution actually handled the event and what they did, right from identifying things like an EKS stack, for instance, binding the solution to a namespace, calculating inventory graph, and so on, right down to ordering subnets through CloudFormation. I'll go a little bit faster here, but the detail is all available if you want to look through. But what we'll see is that even to the point of querying our subnets to make sure they're in place, once they're actually okay, we do things like provision our the document DB instance using the AWS APIs, set compatibility modes, and so on. And eventually, as you start to walk through here, you'll see that there becomes quite a lot that gets done in that couple of seconds that's actually run by EnterpriseWeb to make all of this happen, including things like instantiating the control plane, and I won't spend more time here. Configurations are done through CLI. Eventually, they're even done through proxies such as XOS as required. And then at the end, we actually have even invoking Ansible to be able to run those playbooks that we had. So the resulting system is all auditable in EnterpriseWeb. We can look at the VDUs that were stood up as part of this process or overall. And what we can see is really that sort of that span, right? So we get a fine-grained look at the health and really distribution of this service. You can see the various control plane elements, things like the HHS, P gateway, and so on, the embedded kinds of components, our control plane C, control plane core unit, our distributed units, an EnterpriseWeb controller, and the firewall itself. So the full service has been stood up now in EnterpriseWeb. It's all available for audit, and now we can start to take advantage of this as an end user. So as I mentioned, we're going to play the role of an end user. In this case, it's going to be someone else who wants to just take advantage of that 5G network. It could be the same user we had earlier. It could be someone else in the enterprise. It doesn't really matter. Point is, though, that we can use similar kinds of APIs that are just pointing at different objects inside of EnterpriseWeb to be able to deploy. We're going to go into another customer ordering portal. We have in this instance a set of different objects that have been actually deployed. These are our application packages. So just like we had, we created our open 5GS core service. In this case, we have packages that have already been modeled in EnterpriseWeb for the actual applications we might want to run on top of it. Now, what's nice is that as I start to select this, of course, there's going to be parameters that come forth, things like host names and so on that are specific to the app. But now what we have as part of our target host list is actually the ability to pick that 5G core that we created, or establish a new AKS stack, so as needed. So what's nice here is that it's already going to be sort of it'll already be integrated for us, just by virtue of the fact that the system is going to link this through the API. So I place my order, and then everything is already in place. I can start to enjoy or work with this service. So now I'm going to go in as a NetOps engineer and actually look at what was deployed. So I'm logging into a different module, the application manager, which is where we handle things like application packages. So when I log in here, I'm looking at something that's slightly different. You can see that my catalog here really includes things that are sort of end user specific. So VNFs, CNFs, and so on, they're not the services themselves. This has been sort of, it will give you an inventory of any of the components that you may be interested in. So Homebridge is what we had just deployed. So if I log in here, what I can see is any instances of Homebridge. I can see that there's one that's healthy and available that was just ordered. And if I look at the deployment details, it's pretty simple. It ends up being a pod that's really just been configured in place. So that's really what I'm seeing here. I can click through to where the actual deployment is in that EKS space. I can see the deployment and when it was. And then I can also just click on the link to be able to use this as the end user. So now to complete the demo, I'm going to log in as that business user who ordered the service. So I'm going to go back into my portal. I can see Homebridge here that's been nicely deployed. Same kind of information that we could see right through the system, the same link. I'm going to go in and log in as an admin. And what I have is access to my machine, right? The server itself has been up for 40 days where this sort of home service that this has been deployed onto. I can see any of the logs. I can go into plugins, configurations, etc. All of that is now running, and it's a service that I can enjoy as the end user. So that concludes the demo. We showed a no-code platform-based workflow for doing that full end-to-end deployment. You can see the various components that we were able to both model and orchestrate on the left, including the IoT app at the end. Thank you very much for your time, and please follow up if you have any questions.